How's it going, guys? Welcome to the part 4 of our Python basic series. In this part, we're going to learn about working with numeric data in Python. So, in Python, there's two very common numeric types that people use, and one of them is called integers, and the other one is called floats. And really, the biggest difference between the two is that one has decimals and one does not. So x here is an integer, y here is a float. And to find out, to verify what I said is true, there is a type function that we can use in Python. If we print those, we should see that the first line will come out as saying that the type is an integer and that y should be a float because it's a decimal. So we can see that this is the case, right? This corresponds to x and this corresponds to y. If we, for example, if we also did, more decimals, this is still a float. And if we added a decimal here, both the lines should be float and float. So hopefully that clears up what integers and floats are. Now, for numeric data in Python, what people usually want to do is have operations applied to them, right? Plus, minus, multiply. So I'll also show that here. If I wanted to see, x plus y. Let's just say this was 5.2 and that's 4. So if we printed z here, right, this is 9.2. So this is how you add two numbers, right? I can also do them just with the numbers instead of the variables themselves. So this is subtraction, right, as you expect. You see there's a lot of decimals here with 0, 0, 0.0. Don't worry about that. This happens because we are taking an integer and subtracting it by a float, which is not good practice. So to resolve this, we just make both of them float. And this should be type. This should be still a float. Now, so I'm just going to quickly show the different operations, right? This is multiplication. This is, whoops, that's not right. Multiplication. Let's see what z is. That seems to be right. There is a division. Let's just say this is 4, just to make it easier. This is 2, so it would be 4 divided by 2, so this should also be 2, as we expected. You can see that this is actually a float because division usually gives a float. Since division usually gives us some kind of decimal, if we did multiplication, you can see that it stays as an integer because multiplication rarely gives back decimals. One more thing, a couple more operators that you may need to know is this is called floor division, and what this does is essentially it takes the first number, divides the second number, but it rounds down. Right? So say if this was 5, if we just divided 5 by 2, this would be 2.5, but if we use the floor division, this would be 2, because we rounded down to the nearest integer, which is 2 here. Same idea if we did 7 divided by 2, right? This would give us back 3.5, but if I floored it, I would get 3 back. This is called floored. This is exponent 2, so this is 7 to the power of 2. So 1 star means multiplication, 2 stars means bring to the power of. So this would be 7 to the power of 2, which should be 7 times 7, and that's 49 as expected. Finally, we have an operator called modulus, which is represented by the percent sign. What this does is you can Google what. So this is called modulus. You can Google what this means if you never heard about it. All this does is it tells us how many remainders are left after we divide x by y. So in this case, 8 divided by 2, we would have 0 remainders. So this would be 0. If we had 9 divided by 2, right, we would have a remainder of 1 because 2 goes into 9 4 times, right, which is 8, and there's 1 left, so this should be 1. Very common use case of this is to figure out if a number is if the number that we're modding by is an even or an odd integer, right? So if we had 10, right, this is an even number. As long as we take a number and modulate it by the number 2, if it comes back as 0, we know it's even, because every even number divided by 2, modulus 2 should come back as 0, because 2, an even number divided by 2 should always have the remainder of 0. So, in contrast, if we have an odd number divided by 2, we will always have a remainder of 1, because that's just the nature of division and remainders. So if we did 11 modulus 2, and we'd say we didn't know what x was, we just wanted to check if x was odd or even. So if it comes back as if it comes back as 1, we see that it's an odd. If it comes back as 0, we see that it's even. So this is a very common use case for modulus. But there are, of course, other uses too. Now, these are the operators for, the math operators for numbers. But we also have comparison operators. So these are the ones that these operators you'll see later in the tutorial and in the next couple parts, that it gives back a Boolean. So it gives us back true or false. So what do I mean by that? So for example, a very common comparison operator is equal, right? So here, I will just do it here. So remember, comparison operator always returns back a Boolean, which is true or false, that I talked about in part 2. The math operators that I did all return numbers. Okay. So if we wanted, one very common comparison operator is equal. So this is just checking, hey, is x equal to y? This would be no, because x is not equal to 2. So this would give me back false, right? If we did, which makes sense. So if we did 2, this should be true, right? What if we want to check if x is not equal to y? Well, 2, so is 2 not equal to 2? Well, that's ridiculous. Of course, it's going to come back false, because 2 is equal to 2. So you can see that this is false. So this would be, this Boolean here would be true, because 4 is not equal to 2, right? Sorry to mention, this is an exclamation and an equal sign. So this means this is, again, a comparison operator, and we're checking if x is not equal to y. And indeed, x is not equal to y. Another one is x less than y? No, because 4 is greater than 2, not less than 2. So this is just the left, not sure what people call this. This is the left arrow bracket. You can write it in the comments if you know what this is called. I can't remember off the top of my head. So you can already guess that the other way means greater than, right? 4 is greater than 2, which is true. And then we have, in math, we also have less than or equal to, right? Less than or equal to is the left arrow followed by an equal sign. This is false because 4 is greater than 2, but 4 is less than or equal to 4, so which is true. Similarly, this is greater or equal than. Well, yes, this is greater or equal than because 4 is equal to 4, and 5 is also greater or equal to 4, but 3 is not, right? So these are called comparison operators, and you'll see that these are very useful for flow statements. You know, we might have a program that wants to check, hey, let's just say the user inputs a number and we want to check if that number is greater than the number that we have here. So this is a way to check that, and it gives us back a boolean, and then whether or not it's true or false, we want to do certain things. That's what the comparison operators are for, and then the arithmetic operators should be self-explanatory. Two more are very I would say people, you should know this if you want to work with Python, which is the round function. So all this does is sorry about that. So what the round does, let's chart with, so you put in a number, you put in the float, right? All this does is it rounds to the nearest integer, right? So 3.34, this rounds down to 3, right? This is 3.7, the nearest integer is 4. If we did 5, right, nearest integer is 4, 3.49, nearest integer should be 3. So that makes sense. If you can also add another argument. So round is a built-in function in Python that lets you round numbers, right, up or down depending on what the nearest integer is. So, and you input the number, the number that you want to round as the first argument, and the second argument is optional. And this is the number of decimals that you want. So I want it to the nearest first decimal. In this case, it's this number, and 9 is greater than 5, right? So this rounds to 3.5, right? If I did 5 and then below here, we would have, if I had 4 and below, we would have 3.4. So if I did 2 decimals, well, it would stay the same because we don't know what the rest of the decimals are, right? Finally, we have absolute value, which many of you may know. All it does is it makes sure your number comes back as a positive value, right? You see that my x used to be negative 3.44, but it came back as positive 3.44, and if you absolute value a positive number, it will also come back as a positive number. Finally, a last thing I'll talk about is type conversion. Sorry about that. So type conversion, all that means is now we know that x is a float, right? This is a float, but I can actually make it an integer by using int as a function and sending the number as an argument. So you can see that a float turned into an integer, right? Because it has no decimals, and if we did type of after converting into an integer, you can see that it's an integer. And this is also true if we did the float function, if we converted an integer into a float, right? This would come back as a float. And you can see that if we did, y equals float y, and then we printed out y, you can see that it has decimals now, right? That's decimal still. So that's all the common use cases for numbers. In the next part, we will be talking about... What will we be talking about? We will be talking about just working with dictionaries, lists, tuples, and sets. Hope to see you in the next series, and thank you for watching. If I said any mistakes, please, you can point it out in the comments. And if there's anything that you see are useful with numeric data and I forgot about it, please let everyone know. And thanks for watching.